This is Unit 4, Investigation 3, Lesson 1 and 2. We're starting off with the entry ticket. This should be review. I already set up the synthetic division for you. I grabbed the leading coefficients from the terms in P of x, and then we have our k value, which is 5. So we're going to bring down that 1, and then we're going to multiply by 5 to get 5. And we have to add, so 5 plus negative 1 is 4. And then you have to multiply again by the k value, so 5 times 4 gives me 20. And then if I'm adding 20 and negative 5 will give me 15. 15 times 5 will give me 75. 75 plus 3 is 78. 78 times 5 is 390. And then 390 plus 6 is 396. If you're going to get something like this, if you wanted to write this out as a quotient, it would have been, looking at the concept development for lesson 1, we are going to be looking at this graph. It's actually a roller coaster, which is awesome. The x-axis is representing the horizontal distance, so that's the distance you travel. Think of the horizon. It's going like it's just a distance you're traveling, and it's measured in hundreds of feet. So this 2 is going to represent 200 feet. This 5 is going to represent 500 feet, and so on. Okay. And then the y-axis is representing the vertical distance, which is the up and down distance. So that's measuring the elevation, which is how high up you are in the air or how much you're below the ground level, right? So it's asking us, well, what happens along the ride after passengers have traveled 500 feet horizontally? Well, if I'm looking at this graph, I know that if I'm traveling, I'm starting at 0, right? We're starting at the ground level, and we're going to travel from where we start on the roller coaster up till we get to our first incline, right? To the top of the first incline. Then it's going to travel back down. This is when you're getting dropped, right? That's one of our favorite, that's like everyone's favorite part. Then it reaches ground level again, and then it brings you back up. It reaches ground level and brings you back up, and then you get dropped down all over again. Okay, and then you reach back to ground level. Then you could see that under this x-axis, this line actually continues. And, it would matter if it went back up and met us back at ground level at some point to the right here, but that doesn't happen because you could technically go underground in a roller coaster. That's happened, right? I've been in a roller coaster that goes underground before. And, when you're going under that x-axis, you're basically going negative elevation. That means you're going underground level, which is what you could do if you were in an ocean, and that's ground level, right? That's sea level, ground level. So when you go below sea level, you're going down in elevation. You're going into negative elevation. And that's talking about how high you are in the air compared to ground level, right? So since it doesn't go back up to ground level, we can kind of just ignore that part right here because that's not significant. Okay, so we're looking at the side view of this roller coaster. So it has 2 main drops, and we know that at 500 feet, so at this 5, aka 500 feet, that the ride is probably over. Then it's asking, okay, well, what's the minimum degree of the polynomial shown? I do know from the last investigation, though, that depending on the power of my degree, that I can predict what's going to happen to the root at that point on the graph. Okay, so if there's an x with a degree 1, it's going to be a straight line. It's going to be a straight line right through that x-intercept. If it has a degree 2, it's going to bounce off that point. So it's going to be a parabola right on that x-intercept, which makes sense because any graph that has a second degree has this exact shape. If it has a third power, it's going to look like this, where it has that little flat part in the middle. And if you kind of look over here at the graph they gave us, we know from 0, that's an x-intercept, and it goes straight through. If you look at when x is 3, at this root, we see that it bounces off, right? It creates that parabola. Then we see that this goes straight through at 5. So we know that this is a degree 1, this is a degree 2, and this is a degree 1. So we should be able to make an equation out of this, and we know that this is going to be in total a 4th degree. Explain how you write the factored form. So I'm going to write in yellow here. So I know I have 3 roots, 0, 0, 3, 0, and 5, 0. And we know how to solve for roots. We have to set them equal to 0 to get our root value, right? But you can work backwards too, and we know that x minus 0 or x plus 0, however you want to write that, because it's just 0, and whether you're subtracting or adding 0, you're just going to get x anyway. Okay, so you have x on the outside, and again, we're doing this in factored form. So if we have 3 as a root, then we have x minus 3, because if you set x minus 3 equal to 0 and solve for 3, you're going to get x is equal to 3. Last but not least, we have x minus 5. And one thing we do need to fix is we need to fix our power. So we know that this root is to the power of 1, so we can leave x as is. We know that this 3, 0, that has a parabola. It bounces off that x-intercept, right? So that root is a second degree root, so we can put that to the second power. And then x minus 5 we can leave as is because it's a first degree root, and it goes right through. So you're going to want to check a couple things. You know that your end behavior is going downward. A parabola, a positive parabola would be upward, it's smiling. A frowny parabola would be downward, it's frowning, right? So this would be your x squared, like I showed over here, and then this would be your negative x squared. Just like if you have y is equal to x, which is a straight line up here, you'd have that straight line, but if it was y equal to negative x, you'd have a downward line, straight line, okay? So in this situation, we can assume that there is a negative in front here. And then if you check your answer, and this is 4th degree and it's -1, so if a is less than 0, then we only have these 2 as options, and because it's an even degree, I have 2 downward arrows, so I know that I'm correct. On the next page, we have a summary of what polynomial factors, roots, and x-intercepts are. So if one of these bullet points is true, then that means that all of this is true. We've been working with polynomials for quite a bit now, so and we know that whenever we're looking for our x-intercept, that it's going to be some sort of factor. So we know that we could start with that point. So let's say, okay, well, we know if x minus c is a factor, so let's start with this bullet point, that if this is true, then all the rest is true. Well, we can prove that. X minus c, let's say it's x minus 4. Okay? Well, then if x minus 4 is a factor of the polynomial, then first we could check that C0 is an x-intercept of y is equal to p of x. So we know that x minus 4, if we set this equal to 0, because it's a factor, we can solve for what x is going to be, our x-intercept. So we would have an x-intercept at 4, 0, which makes sense if this is our c value. So it would, in fact, be an x-intercept. Also, okay, so x is 4 and y is 0. So another one of these bullets is, okay, well, if p of c is equal to 0, which it is, because the y value here is equal to 0, that's essentially telling you that, okay, well, where does your polynomial value hit 0, which is your x-intercept, because your p of x is your fancy way of saying your y value, right? Because your function value depends on your x value. So y is dependent on x because p of x, your polynomial in terms of x, right? So your y value depends on what your x value is. So y is the dependent variable. If we're looking at this graph here, we're just going to jump the gun a little bit. You're looking at right here 4, 0, which is an x-intercept, right? But it's also a factor. And the y value is 0, so at this point in this polynomial, when it hits 0 on the x-axis, that's telling you that your y value is 0. So your x value has to be your x-intercept if y is equal to 0. So this one has to stand as well because your x-intercept is your root. That's what gives you when your function is going to hit 0. Lastly, if you have your polynomial and you're dividing by some sort of factor of it, the remainder will be 0. And that makes sense because that would mean it's perfectly divisible. Even if we used a number like 12 and we divide it by 4, well, we know this is going to equal 3, and 4 and 3 are both factors of 12 because there is no remainder. We can check that all 5 of these components are true just by giving 1. So it asks us to sketch your graph below. So if you used Desmos to help you could have gotten the same exact rough sketch. We'll go to Desmos in a minute though. It says based on your sketch, what must be the factors? Well, we know that -1, 0, 2, 0, and 4, 0 are x-intercepts. So in factored form, x plus 1, x minus 2, x minus 4. If you used Desmos to help you sketch the second graph, you would have gotten the same line in green. So if you were to compare both graphs, your f of x and g of x, you're going to notice that they have the same exact factors, but that doesn't mean the equation of each graph is going to be the same. So if we were to plug this equation, x plus 1, x minus 2, x minus 4 into Desmos, we're looking at this f of x equation, and this is our factored form equation. So if we graphed both of them, we can see that these are the same exact line, because it doesn't matter what color we use, it's on the same exact line. We need to find the factored form for g of x. So if this is our factored form for f of x, well, let's compare it to g of x. We know that these are not the same line, so we need to adjust our equation for our factored form for our g of x equation, okay? So now, if you kind of notice, looking at your equations, we're taking f of x, and to get g of x, we're essentially dividing by 5. So if we had 1 and x to the third, we're taking that 1 and dividing it by 5, so we get 1/5 x to the third. If we take our negative 5x to the second and we divide by 5, we get a negative 1, which is what you have in g of x, negative x squared. Again, if you have 2x in f of x, then you take that divided by 5, and you will see that you have a 2 divided by 5x in your g of x equation. Then, if you're looking at the 8 in f of x, you divide that by 5, and in g of x, you're going to see 8 divided by 5. So we can assume here that if I put 1 over 5, because we're dividing by 5, in front of this factored form equation, then we get the same exact line that we need for g of x, but in factored form. And on the next page, where we have a couple problems to solve, we're trying to prove the equivalence of them in a sense, right? To start, we know that they have x minus 1 in common, and they have x plus 2 in common. So we're trying to figure out, is x plus 2 times 4x minus 2 equivalent to 2x minus 1 times 2x plus 4? Well, we can factor. So on this side, we can't do anything with x plus 2, but we can factor out a 2 from 4x minus 2. So we could have x plus 2 times 2 times 2x minus 1. Because if you distribute this 2 back in, you get 4x minus 2. On the other side, we can factor out a 2 from over here. So we still have 2x minus 1, and then we have a 2 times x plus 2. So now we can look over here at these two factored forms, and we know that they each have a 2, so we can eliminate that. And they each have x minus 1 and x plus 2. So we know that these are going to be equal. 7 asks us to take the same exact polynomial we started with, but they ask us, okay, well, is there an easier way to basically write this in factored form, right? Well, we know that if we factor out a 2, we'd get 2x to the fourth plus 5x to the third minus 3x to the second minus 8x plus 4. But that doesn't really give us anything. We'd have to do a lot of long division to try to figure out what the factorization of for this h of x would be. So that brings us to our next question, number 8, and we could say, okay, well, how about let's graph this? And I've already graphed this for you in Desmos right here. And one of the factors is 0.5, which is 1/2. So the graph that we're going to draw is going to be a little hard because you have to do a rough sketch. But we have -2, 1/2, and 1 as our roots. So here I've done a little rough sketch of what the graph looked like. And from here we actually can make factored form because we know each of our roots. So we're going to have h of x is going to equal x plus 2 times x minus 1/2 times x minus 1. But now we have to kind of be careful of what happens at each of these x-intercepts. So as you can see at -2, 0, that at that root, the polynomial bounces off there. So that means that this is going to be a degree 2 root. The other two roots just have a straight line right through it, so we know they're to the first degree. And we know that in total we have 2, 3, 4. So we have fourth degree total polynomial, and we know that the end behavior matches up with this being a fourth degree positive polynomial. Moving on to concept development for lesson 2, we have this first question where we have to distribute. So we're multiplying two expressions together. When you distribute, you get these two expressions, and then you got to combine your like terms. So here you're going to notice that negative 28x and 28x will neutralize to create 0. In B, you're going to see that 20 and negative 20x will neutralize to create 0. So you're going to be left with 16x squared minus 49. And here you're going to be left with 4x squared minus 100. So your middle terms will neutralize, and it asks you now to factor the following expressions. So the middle terms will neutralize, and now we have to factor these as a difference of squares. So we viewed a Khan Academy video on this, but I'm going to re-explain it. So basically, this A and B is what we saw for up here in green. So 16x to the second minus 49, and then we have a different example for B. But we can notice here that 16 and 49 are both perfect squares. So we know that we can take 4 and square it to get 16. We also know we can take x, and if we square that, we get x squared. So I know I can take 4x, and if I square this entire term, 4 to the second gives me 16, and x to the second gives me x squared. So this works. Now I got to move on to 49. That's the easy part, though, because I know that it's going to be 7 squared. So I'm going to have minus 7 squared. And these are the same exact equations. They're equivalent, but this one is just factored as a difference of squares. Now we have 81x to the fourth minus 10,000. So we know that 9 squared will give me 81, and I know that x to the second squared will give me x to the fourth. So I just have to square this term. And now for this one, well, we have 4 zeros. So this is most likely going to be 100, right? So I have minus 100 squared, because if you take 100 and you multiply by 100, you get those 4 zeros. You get those 4 zeros for that 10,000. So here, 9x squared is going to give me, if we square 9x squared, we get 81x squared. Here we square 100 and we get 10,000. So both of these will check out. So if we were to generalize an equation for the difference of squares, we're going to have any x value squared minus any a value squared is going to give you a factorization of x minus a times x plus a. Moving on to lesson 2, concept development. We're going to be practicing long division. After you're done with your long division, there's 6 problems. You're going to see, okay, well, is there a pattern? We can formalize 2 different types of factorizations. So the difference of cubes is when you're subtracting 2 cubes. The sum of cubes is when you're adding 2 cubes. Okay, and these are the general equations for each. So we're going to be using those today to figure out what the factorization is without having to do a bunch of long division, right? Because that's very time consuming. So if I take x and I put that to the third power, I get x to the third. And then if I take 2 and I raise it to the third power, that will also give me 8, because 2 times 2 times 2 is equal to 8. Okay? So now that I have my a and b values, I can come up with my equation. So this is a sum of cubes, so I'm using this second equation. I have a plus b, so I have x plus 2 here. Then I have a squared, so I have x, so I need x squared here. Then I have to subtract a times b, so 2 times x will give me 2x.
and then I'm adding b squared. So my b value is 2, so I have 4 here. Now, if I'm looking at this b example, I know that 3 to the third will give me 27. I know b to the third will give me b to the third power, so I just need to cube 3b. Here we have another x cubed, so if I just subtract x but cube that, I will get minus x cubed. So we have the same exact sentence. Now we have our a and b values, and we can solve. And this one is a difference of cubes, so we're going by this first equation. So we have a minus b, and in this case we have 3b minus x. Then I have a squared, so I have 3b, and I have to square 3b. So I'm going to get 3 squared is 9, and b squared is b squared. So I have 9b squared here. Then I have to subtract a times b. So if I'm multiplying 3b by x, I just get 3bx. And then lastly, I need to add b squared, which is x squared. And this is my full factorized form.